All right, so this is day 2, graphing quadratics, analyzing graphs. And there's a lot of vocabulary in this one. So the first thing they have is the vertex, which is the turning point of the quadratic graph. We kind of already talked about that one. So here, if you look at this graph here, because it's a nice big one, the turning point would be right here because that's where it goes from kind of going down to going up. So right there, that is your vertex. Now, your vertex can be a minimum point, so it could be the lowest point of your graph. Like, for instance, here, this is the lowest point on the graph, so now your vertex would be a minimum. And this is said to open up because the V kind of looks like that, the opening is up. Or it could be a maximum, which is like this one here, where your vertex is the largest, the highest point on your graph, and this is said to open down because now your U is going the other way. So a reflection is when the graph is opening down. So this would be a reflection. This would not be a reflection. The axis of symmetry we mentioned already. The axis of symmetry is a line that you can imagine folding the graph along that would split the graph perfectly in half. It will be a vertical line through the vertex, so the equation is always going to be x equals whatever the x value of that vertex is. So here, you can kind of imagine, here, let me just draw a graph. If we had some graph here, and let's just say that the graph is this, y equals x minus 2 squared plus 3. We know our vertex would be at 2, 3. So I'd go over 2, up 3. And I'm going to use my pattern over 1, up 1, over 2, up 4. 1, 2, 3, 4. I'm going to reflect those. So this here would be my parabola based on this equation. And then my line that of axis of symmetry, the line that would go through my vertex would be this line right here. And that's called my axis of symmetry. And the axis of symmetry is always going to be x equals whatever the x value is of your vertex. So in this case, it'll be x equals 2. Please remember, it's always going to be x equals, and it's always going to be whatever the opposite sign of that is. So x equals 2 is your axis of symmetry. Increasing is the part of the graph. It is read when you read it from left to right, where is the y is going up, and decreasing is where the y is going down. So if I have a parabola or a graph, I always think of it as kind of riding a roller coaster. So if I have some graph that looks like this, and let's just say it, let's just make up some points. It looks like this here. I always think that you're always gonna start riding your roller coaster from the left, just like you read left to right. So if I got on my roller coaster here at this point, I'd be going down first. So it would be decreasing. It's decreasing to the left of my axis of symmetry. So it's decreasing when x is equal to 2. And it's going to be increasing over on this side. If my graph were the other way around, my graph looked like this. Again, I'm going to start on the left. So now if I get on here, my graph would be increasing first. And then after the vertex, it would be decreasing. And then the domain is the set of all possible inputs, which are your x coordinates. So if you look at your graph, if you look at the right side of your graph and the left side of your graph, or look at all your x's, is there any value that x cannot be? Well, this goes on and on and on forever in this direction, and this goes on and on and on in this direction. So your domain for x will always be all real numbers for a parabola, for a quadratic equation. But the range is all the set of your y values. So now you're going to look at up the top of your graph and then the bottom of your graph. You're going to look at your y values. Well, all my y values on this graph here's the lowest point, and they're all up like this. There's nothing below my vertex. So the vertex is going to kind of set where your range is. So my range in this case would be greater than or equal to 0. If we had another equation, let's just draw another one. Let's say we had a graph that looked like this. And let's just say our vertex was at 2, 3. And let's just say it opened down like this, where this is 2, 3. Now, if I take a look at my domain, again, your domain is always going to be all real numbers, and you can write all real numbers by kind of writing it like that, or you can write it out, all real numbers. But now my range, this here is the highest point of my y's where my vertex is. All my values are below that. So my range is going to be y has to be less than or equal to 3, because I don't have any y values that are bigger than 3. All right, so let's take a look here. Your parent function is defined as the easiest or the simplest quadratic function there is, y equals x squared, where your vertex is at 0 and 0. So your vertex is at 0, 0. The vertex is a minimum because it's the lowest point. The axis of symmetry is x equals 0 because it's going to go right through this point, would be the middle of your graph. The graph is increasing to the right of the vertex. So right here it's going up, and it's decreasing to the left of the vertex. So on the left side, remember you start here, so it's going down. The domain is always going to be all real numbers. You don't even have to think about that one. And here the range will be all real numbers greater than 0. So you could just say y is greater than 0. That would be fine. All right. So let's just take a look at another example. If you have a graph now that's not your parent function, let's just take a look at this graph. Well, your vertex is at 2, negative 2. The axis of symmetry would be the line that goes through that, and it's always going to be your x value. So your axis of symmetry will be x equals 2. It is, if you say, is that going to be a minimum value or a maximum value? Well, this is the lowest point on your graph. So in this case, your vertex will be a minimum value. Where is the graph increasing? So here, if I get on my roller coaster on here, it's decreasing on the left, so it's increasing on the right. It's increasing wherever x is greater than 2, because this is the point where it starts increasing at 2. So greater than 2, it's going to start increasing. And where is it decreasing? Well, it's going to decrease when x is less than 2, because on the left side of the graph, it's decreasing. The domain, we had said, is all real numbers. The range, well, again, I have everything is going to be above my negative 2 value. So my range is going to be y is greater than negative 2, greater than or equal to, sorry, I should have said greater than or equal to negative 2. And how does the graph relate to the parent function? They're really just talking about the shift. So it has a horizontal shift to the right of 2, and it has a vertical shift down 2. And same thing on this one here. Now the vertex is at 2, 3. The axis of symmetry, again, this is still your middle. This is x is 2. Now my vertex is a maximum because this is the highest point of my graph. If I get on my roller coaster, I'm increasing on the left and decreasing on the right. So to the left of the graph is where I'm increasing, right here, right? To the left of my vertex. So where x is less than 2, I'm going to be increasing. To the right is where I'm decreasing. Again, my domain is all real numbers. My range, everything is below my vertex here. So my range is y is less than or equal to 3. And how does it relate to the parent function? I have a horizontal shift of +2 and a vertical shift of up 3. So let me know if you have any questions.